This is a video clip for the AEDT 1120U Foundations of Digital Teaching and Learning Technologies course from UIT, and the title of this video clip is Programmable Devices Concept. The analysis questions for this video clip are as follows. Number 1, what are mainframe computers? And then do a search for ENIAC and UNIVAC and determine what were their roles in mainframe computer development. Number 2, why is the ability to program a device a significant improvement over previous devices? Number 3, what is programming and what are programming languages? Number 4, what is the role of the CPU in a computer, and why would some consider the CPU, the central processing unit, to be a computer, and all other functions and devices are peripherals? The following two clips outline some of the more important historical evolutionary ideas pertaining to mainframe computers. While it is expected that you will explore some of the technical features and issues that arose along the way, the treatment in this session and in succeeding sessions will focus on concepts that will have a bearing on the use of computers and their derivative technologies in teaching and learning environments and contexts. The idea of mainframes as large computers arose early in the history of computers as the mechanical and electrical components were large and expensive, and they consumed a large amount of electricity to power the device. Reports about the lights of Philadelphia dimming when ENIAC was first turned on are easy to find. Initially, mainframes consisted of one central processing unit, a CPU, with various peripherals. Subsequent models, including machines made by companies such as IBM, International Business Machines, Remington, later called Sperry Rand, Burroughs, Digital Equipment Corporation or DEC, Cray, and others, increased in speed and computing power by increasing the speed of the CPU and then incorporating multiple processors that worked in parallel to each other. Please see sites such as The History of Mainframe Computer, 2008, and the URL is given on the slide, and Mainframe Computer 2012, retrieved from Wikipedia, and you will get the URL in the presentation that is included in the Blackboard portion of this course. Initial computing devices such as Charles Babbage's analytic engine were designed as calculators that used mechanical gears. This is similar to having mechanical devices that have one purpose, such as a wristwatch. Many people are currently beginning to reconsider the idea of wearing a wristwatch as a way of keeping track of time, and may taking to wearing one only as a fashion accessory. The more attractive alternative is to have a cell or smartphone that not only tells time, but can also be used as an alarm clock, a communication device, and a means of aggregating, filtering, and connecting information. One of the major differences between a watch and a cell phone or a computer is due to the ability of cell phones to be programmed to perform a myriad of different tasks or to become a wide variety of tools. Programming essentially entails providing the computer a series of commands or calculations, since the computer at its most basic level is only capable of doing simple addition calculations that are required to be carried out. As the capabilities of the machine increased, the sophistication of the command structure increased as well. Programming of computers was originally carried out by physically rewiring the machine, as in the case of very early computers. Soon other methods of inputting the commands were found. These included the use of punch cards, paper tape, which relied on the absence or presence of holes in the card stock or the paper to represent zeros or ones, the digital language used to structure the command so that the computer can understand it. Quickly it was found that magnetic tape and disks could be used. The orientation, or changing the charged particle from a north-south or to a south-north orientation, could be interpreted as digital values of 0 or 1. The charged particles required far less space than holes on paper and could be detected by a reader far quicker, allowing for faster load or boot times. For much of the history of computers, we'll be relying on a series of video clips that have been posted on YouTube. In this case, we'll be making use of a 5-part series called GIGO, Garbage In, Garbage Out, Computer History, A British View. The series was produced in 1969, so it is a little dated, but it does a good job of covering much of the required territory. Note the personal reactions that are reported at the beginning of the clip. Reflect on the question of how valid are the views that are expressed when viewed from 2012. In Part 1, the series covers topics such as early uses of computers for the control of manufacturing processes, or finance and accounting, or airline scheduling, and finally, health analysis. Computers are defined as general-purpose machines that process information that can be programmed for specific use, and an explanation of binary functions is given. So please take a look at GIGO, Garbage In, Garbage Out, Computer History, A British View, and the URL is given on the slide, and it will be provided in the presentation PDF in Blackboard as well. Following the previous video clip, I'd like you to take a look at Part 2 of the same series. In Part 2 of the GIGO, Garbage In, Garbage Out, Computer History, A British View, the components of a mainframe are described. Reflect on the extent to which the components still exist in modern computers. Computer inputs are described, and the ones that are described in the video clip are punch cards, paper tape, and magnetic tape. Memory is talked about, specifically random access memory, or RAM, and it functions as an information store. Intermediate memory is also talked about, and this could be viewed from the perspective of read-only memory, or ROM, R-O-M, and this can be found in terms of hard disks in the present computers. The third component is a logic unit, binary adder only, so it can only add. So you'd have to do some interesting manipulations in order to be able to get it to doing multiplications, divisions, etc. Outputs. Usually this was done initially anyways on a high-speed printer, and then finally a control unit. So it controls the sequence of information that is going to be processed. The video clip also describes the functioning of computer instructions or programs, system analysis functions using flowcharts to determine the logical operations which are required. It talks a little bit about programming languages, and there are some examples of high-level languages that you might be familiar with: Fortran, COBOL, Whatcom, and the ones that I originally learned, APL, which stands for A Programming Language, or PL1, Programming Language 1. And then there are compilers which are built into computers. Essentially, these are language translators designed to transfer high-level language code into binary code, which is what the computer understands. So please take a look at GIGO, Garbage In, Garbage Out, Computer History, A British View, Part 2, and the URL is given on the presentation in Blackboard. An additional series that you might want to take a look at, and this is not required, but you might want to take a look at this. So this page will provide links to another series that looks at mainframe development from another perspective, and it's entitled The Big Iron, the Mainframe Story, and there's a 5-part series that essentially follows through a number of decades since the 1960s. That brings us to the synthesis questions for this video clip, and they are as follows. Number 1, what is the relationship between Moore's Law and the continued development of CPUs? You'll have to look up Moore's Law and what that stands for. Why is this important for anyone who uses digital technologies? Number 2, what are mainframes used for, and how has this usage changed over time? Why has it changed? Number 3, why do some portions of the population react negatively to the introduction of computers? What are the implications of this for the use of digital technologies for adult education? And number 4, how has the concept of programmable devices changed the world? What are the implications for adult education? That brings us to the end of this video clip.